So this is obviously not your usual coordinate geometry problem in school, because in coordinate geometry in school they give you the axes, right? But you can still get a geometry problem without axes, and you can still solve it with coordinate geometry. Okay. So let's call this one R1. So basically, the trick with coordinate geometry is to pick nice axes, yeah?
Mhm.
So this axis is pretty good. It goes through both centers, yeah? Like make the origin, yeah. Okay. And so what we're trying to do, obviously, so so this diagram might not even depict it, but we have A is 0. The A could actually be such that the circles intersect, or it could be on the other side, but as the line during the centers is lined up. Okay. And basically, this is R2, this is R1. And what you want to do is you want to find the set of all points with the same power, both. Okay. So you want like a point X, Y, right? It has the same power. So what's the power? The power is the distance squared minus the radius squared. So d1 squared minus r1 squared has to equal d2 squared minus r2 squared, right? So actually knowing that, you could probably finish it off from here. So the d squared is just the distance formula. So that's just x squared plus y squared. R1 is just given as a constant, right? And then d2 squared. Now there's an a there. That's the only difference, yeah? Okay. So the y's immediately cancel, which is good, right? So we don't even need the diagram anymore. The diagram's actually just getting in the way now, because so the circles might actually intersect. We didn't actually know that. From the algebra, it doesn't tell you the circles don't intersect, right? That depends on how big A and R are. But okay, so when you do the algebra with this, you see the y squareds cancel, right? The x squared will also cancel. So you know it's actually an equation of a straight line, you know? So if you put it all on one side, you actually get 2ax equals a squared plus r1 squared minus r2 squared, you know? So x is equal to a on 2 plus r1 squared minus r2 squared on 2a. Okay, so what's the significance of that? Well, it's saying that the thing with the equal powers, so it's called actually the radical axis, has the same, it's a straight line, right? Yeah. So it's a straight line, okay, and it should be closer towards the smaller circle, yeah? So if R1 is smaller, it'll go negative. So A on 2 is the midpoint, right? So if R1 is smaller, it should go closer to R1. If R2 is smaller, it should go closer to R2, the other circle. And it's perpendicular to the line joining the centers, yeah?
Yeah.
Yeah, so in your school language, which used to exist, you'd say the locus of points with equal powers is a straight line that's perpendicular to the line joining the centers, and it's about halfway minus r squared minus, like, you know what I'm saying? Um, yeah, and where it is, it's given by that formula, okay? And so, and the two circles don't have to be far away. They could be inside each other. It's intersecting. There was nothing. The only thing that it can't be for this formula to work is A can't be 0, right?
Yeah.
Which means they can't be the same center, okay? But I think if they're the same center, it should be obvious. Okay. Yeah. So they could intersect. They could even be like this. I guess this is probably the hardest case. It's like this. Yeah, but no matter where they are, as long as they don't have the same centers, then it's a straight line. Okay. Actually, if they do have the same centers, can you see that which points would have the same power? So how would it even work? The D would be the same, right? But the R's would be different. So they can't have the same powers if they've got the same center, yeah? Does that make sense? Like if the two circles have the same center, then D would be the same. D1 equals D2. So they would cancel. But then like R1 squared should, but R1 is not equal to R2, so that's a contradiction. So okay, or if R1 is equal to R2, they're the same circle, so every point has the same power. Yeah. Yeah, so that's called radical axis of two circles. But it's not so much important what it's called, it's more important that you can figure out how to do it using your coordinate geometry, right?